So up until now, every time you've given an answer like all real numbers, that seems like, why do I have to say real? Well, because there are imaginary numbers.
Axioms.
Huh?
Axioms.
Yes. All right, so if we look here and we read through, it says sometimes we encounter problems that have no real solutions. Do you remember seeing graphs that look like that? And your response is there's no real solutions because it does not intersect the x-axis. Remember, your solutions are the roots, the x-intercepts, etc. So there, you never, well, you may have said, but your teacher never said there are no solutions. She said there are no real solutions because there are imaginary roots, imaginary solutions. Okay? When we have an imaginary number, we indicate that with the letter I. The letter I tells us that it is an imaginary number. Okay? So the entire imaginary number system came about because people had a problem. They could take the square root of a positive number. We know the square root of 9 equals 3. And the reason we know that is because 3 times 3 equals 9, or in the case of what you just said, Logan, negative 3 times negative 3 equals positive 9. We're not going to really focus on that piece right now. Okay? But when we try to take the square root of a negative number, we can't do it because there's no number multiplied by itself that will give us a negative. 2 negatives multiply to give a positive. 2 positives multiply to give a positive. So the square root of a negative number brought up this entire system of imaginary numbers. So the letter I equals the square root of negative 1. The letter I equals the square root of negative 1. Okay? So if I took the fact that I equals the square root of negative 1 and I squared both sides, we know that the squared cancels out the square root, and we would be left with the fact that I squared equals negative 1. Okay, so those are 2 important things to know, to memory. I equals the square root of negative 1, and I squared equals negative 1. All right. So looking at the first example there, when I see the square root of negative 121, I could break that into the square root of negative 1 times 121. Okay? We just learned that the square root of negative 1 equals I, and we know the square root of 121 equals 11. Okay? So I'm done. That's my answer. The only thing is grammar. How do we write it? In what order is normal? We're going to put 11I. That is the normal form to write it in. Good. So again, every time you see the negative inside the square root, it comes out of the square root as an I. So when I see the square root of negative 28, I pull the negative out as an I, and I'm left with square root of 28. Now 28, I know how to do that, right? We're going to simplify it. We're going to break that 28 up into 4 times 7. 7 is not a perfect square. So square root of 4 is 2. 2i square roots of 7. Okay. It's not too tough. It's not too complex. Weird, yes, but tough, no. That negative comes out as an I. Then I've got the square root of 99, which is 9 times 11. The 11 is not a perfect square. Square root of 9 is 3, so I've got 3i square roots of 11. Because those have an I in the number, those are all 3 imaginary numbers. Okay? All right. Now we're going to look at multiplying. Okay? This is important to put in your head to know. We've been talking about how outside multiplies with outside, inside multiplies with inside, right? That is true whenever A and B are positive. Yes?
It's
0? Okay. But 0 is a non-point here, so we're not worried about that. So we can multiply a times b inside the square root only when a and b are positive numbers. Okay? So, are these positive numbers? No. So I cannot just multiply the negatives away. I have to account for that negative as the square root of -1, which comes out as I. So I'm going to rewrite each one separately. I've got I square root of 7 times I square root of 2. All I did was pull out that square root of -1. Okay? Now, A and B are positive, right? The numbers inside the square roots are positive. So outside multiplies with outside. I times I is I squared. Inside multiplies with inside. 7 times 2, that gives me the square root of 14. Now move up in your notes. Look towards about halfway. What does I squared equal? -1. So I cannot leave it like that. I have to say that I squared equals -1, so I have negative square root of 14. Okay? Okay, so the I does not just come out as a negative. I is not a negative. I is the square root of -1. But once I square the I have -1. All right, so let's rewrite this one. We've got I square root of 3 times I square root of 5. I times I is I squared. 3 times 5 is the square root of 15. Can I leave that answer? No. I squared equals -1, so negative square root of 15. Seem good? All right.
Miss, could you solve? It's negative 15
So-
because is the square root? Oh wait, no.
So, and all the rules you know actually are in the real number system. So we're going to like rethink things differently with imaginary numbers. Okay, so let's look at the next one. Again, just pull out the I, square root of 6, times I, square root of 2. We get I squared square root of 12. I've got to change that I squared to a -1. Can I do anything with the square root of 12?
Yes.
Yes. So I'm going to have negative square root of 4 times 3. The 4 is a perfect square, the 3 is not. So we've got -2 square roots of 3. Okay? Seem good? All right, we ready? Now we're going to look at complex numbers. Complex numbers. Guys, y'all do not take physics yet, right?
I know.
You do? Are y'all done complex numbers yet at all? Okay. Complex numbers are used in physics. Any electrician has to work with complex numbers. Any electrical engineer has to deal with complex numbers. Electrical currents utilize the concept of complex numbers, the flow. All right, so a complex number is a combination of a real number and an imaginary number. Okay, so I'm going to write a complex number inside the box. Okay, that's a complex number. The real number is 3, and the imaginary number is 4i. Together, they make up a complex number. This is what a complex number looks like written in standard form. Okay? What a complex number looks like written in a standard form. You can add and subtract complex numbers in the same way you've combined algebraic expressions. That I works exactly the same as if it was an x. Okay? You're going to keep your real numbers and your imaginary numbers separate. Okay? So when you look at that first example, it has parentheses, but is there anything I need to distribute inside the parentheses? No. So I can just get rid of them. I'm going to rewrite -2 plus 5i plus 1 minus 7i. We're going to combine like terms, real numbers first, because that's what it goes in standard form. So real, negative 2 plus 1 is negative 1. Imaginary, 5i minus 7i is negative 2i. That's all it takes. You already know how to do this. It just looks different because of the I. That's it. Now, look at this one. Yes?
Can you like solve for I, or is it just I?
So,
It's just I.
you wouldn't solve for I because I is a number.
It is.
I is not a variable.
So that's just how we're
Oh,
gonna do it.
Yeah.
Yep, I equals the square root of negative 1.
Represents an idea, not a number.
Yeah. If you were going to rewrite this at all, and this is not how you would want your answer to be, it would be negative 1 minus 2 times the square root of negative 1, right?
So it's just I.
Yeah,
This
and
is-
that's, so it's just I.
This is instead of I
Yeah.
representing some
we'll never
some
have to,
variable, it's
find it,
representing
that's
some
what's-
idea.
So I is the simplest form of that variable. I mean, not variable, of that number, yes. But it's just a number. And what does it equal? The square root of negative 1. All right. Yeah. All right, so let's look at the next one. This was an Algebra 1 problem. If it had been x's, we need to distribute that negative before we begin, correct? So 4 plus 6i plus 1 minus 2i. Combine like terms. 4 plus 1 is 5. 6i minus 2i is a positive 4i. Okay, seem good? I'm going to do this last example. Okay, so we've got negative 8 plus 3 plus 2i. Don't forget to distribute. So minus 7 minus 5i. In this case, I've got 3 real numbers. So negative 15 plus 3, negative 12 for my real. My imaginary, 2i minus 5i is minus 3i. Okay, seem good? All right, I want you to do the one I skipped right here, and then I'll call for an answer in a minute. We'll check our work, okay?
Rainbow method.
Rainbow.
I've heard of that.
That's just those arches. People call it the rainbow method. You'll see. All right. Mia, what did you get? Yeah, for this one right here that we just did.
I got negative 4 minus 14.
Okay, so tell me about the negative 4. What happened to the 14 at the beginning?
Oh, I did say 14.
Okay,
But it
so
was number 1.
that's okay. Sydney, what'd you get?
Oh, no. The other one. I was like,
Sydney, what'd you get?
I think that's the same issue, yeah.
Bianca. I'm going to Bianca. So it is that what you got? 10 plus 14i. Awesome. Yeah, don't leave things behind. They get their feelings hurt. They cry. All right. All right. Moving on. Multiplying. Okay? So when you multiply complex numbers, you're going to use exactly the same methods you've used for multiplying when there were x's or y's. You do exactly the same process. You distribute when necessary. You use FOIL. You use the box method. You use the rainbow method. However you did it before, you do it still. Okay? All right. So I know how to do this if it had an x here. I'm going to do it the same way. So 5 times 2i equals 10i. Done. Okay. Negative 3i times 2i. Negative 3 times 2 is negative 6. I times I is I squared, which brings us to this last comment in the paragraph. Only thing additionally you have to do is if you get an I squared, you have to replace it with negative 1. So this is actually negative 6 times negative 1, which means my answer is positive 6. Okay, so again, if you have to distribute, you distribute. So we've got 24i plus 8i squared. But I'm not done, right? I squared equals -1, so we've got 24i. Let's see, 8 times -1 gives me -8. Now look up at the top at standard form for a complex number. Is this written in the correct order?
Nope.
It is not. We need it to have the real number first and then the imaginary. -8 plus 24i. Okay. Alrighty. So look in here, okay, foil, this is the rainbow. We're going to do 2 multiplications this way, 2 this way. Okay, all 4 multiplications. 1 times 3 is 3. 1 times -6i is -6i. 4i times 3 is plus 12i. 4i times -6i is -24i squared. Okay. All right, what do I have to do with that I squared? It's actually a -1, so I'm going to change it to a -1. So we've got 3 minus 6i plus 12i plus 24. Real numbers first. 3 plus 24 is 27. Imaginary numbers second. -6i plus 12i is positive 6i. Do y'all want us to do foil again, or you feel
Foil it
good?
again.
Foil again, all right. All right. Again, we're going to do it twice on top. 18 minus 6i. Twice on bottom. 36i minus 12i squared. So we've got 18 minus 6i plus 36i. What's going to happen to this value at the end? Plus 12, right? The I squared is -1, so I've got plus 12. Like terms, real first, 30. Imaginary second, plus 30i. Seem good? All right, so here is the deal with your homework. It was supposed to be online homework, but the textbook the problems in the textbook are not matching the problems online. So it is textbook homework instead of online homework. So we can grab textbooks, or you can grab your iPad, because I want to make sure you see how to get to your textbook in the iPad. But the assignment is listed on top of your notes, right? It says what your homework is. Okay?
I think we all got the books.
We're just doing
during,
13 to 12.
like,
You didn't get me
before,
books.
because
You didn't get any books for this class. I
I
have a class set here, and your textbook is on. Do you remember where your textbook is in your iPad? Okay, we'll do that. We'll do that now. Either grab a textbook or an iPad, either way, so that you can see the textbook. Jalen, take a picture of me.
I know that's what I was
so,
Jalen, you wanna do that?
Yeah. Yes, you're gonna need a sheet of paper, and if you don't have one,
We're just gonna share it.
I have one in the, I have one over there.
so,
I have one over there from the, not quite yet.
so, which one of them? Which ones?
I know, dude, I was about to go get mine
We
now.
do all of them?
Four periods?
Take it. Yeah.
All right, I'm gonna pull up, if someone will log in, I'll use your iPad to show people where the textbook is, in case you're not sure. We'll get going.
person has like 12 tabs open and 2 windows.
Yeah, I have paper if you need it. Just grab it from the tower back there with the Kleenexes. I have paper on it. Yes, please.
Send us.
Yes.
Look what someone did.
They double screwed it.
And they did this. Yeah, let me just.
Well, we've been having trouble with the iPads all day.
Yeah, but this looks like it's been done on purpose.
Yeah, I think so. No, definitely. All right, so a quick comment. Okay, can I borrow this, babe? All right, so looking at the iPad, when you go on, this is where you would go for your assignments. Great. But if you go to your resources, this first tab is your textbook. Okay, when you open your textbook, you click it open. Look at your notes. What page is your homework assignment on?
47.
What page? 160, 161. See this little tab up here? Okay, in a minute, Logan, leave it, let me focus them right now, okay? All right, hit that little tab, whatever page you want to go to, in this case 160. Okay, which problems are you going to do? It's listed at the top of your work there, okay? All right, but we're going to do one together because it looks way more complicated than it is. We're going to do number 13, which is one of your homework assignments, okay? At number 13, in case you can't read it, I'm going to write it again. 4x plus 2I equals 8 plus yi. Okay, guys, are we focused in on this? Great. All right. The only thing I need to make sure you realize is the real numbers and the imaginary numbers do not interact in any way. They don't do anything together. So when I see this, all I have to worry about to solve for x, is that a real or an imaginary? Is the real. So all I have to worry about is how do I make 4x equal 8? Well, if x is
2.
x is 2. Done. Now I'm going to look at this one. All I care about, imaginary connects to imaginary. 2i equals yi. You can solve, and we can solve if you want to, or you could use your brain, your logic. 2i equals yi. What does y equal?
2.
2. Yeah. If you needed to solve, you could divide both sides by I, and you would get y equals 2, right? All right. And I think when you're looking, like, yeah, you're going to do, like, the odds. You have 1 through 4, but I didn't put it up on the board. Take a look at that. Yeah, that should be fine. So let's read the first question together, okay? And let's brainstorm what the answer is, since we're used to kind of having things helped along the way. I know you complain about an online textbook, but it helps you like figure stuff out. All right, so what is the imaginary unit I defined as? Someone tell me, what is I defined as?
Square root of -1.
Square root of -1. The imaginary unit I is defined as the square root of -1. How can you use it? To find the square root of a negative number. Two is easy, you should have no problem. 3 is easy. Write a sentence, you should have no problem. 4, probably no problem. Let's look at number 4 together. Which one does not belong?
0i.
Huh? 3 plus 0i, does that have an imaginary piece to it? No, because 0i means there is no I. It's just 3. So the one that does not belong is the 3 plus 0i. But you need to explain why doesn't it belong. That's on you. Okay? So all of these are imaginary except not that one. Okay.